Hi, I'm Paco Nathan with O'Reilly Media, and it's a pleasure to get to talk with a good friend, Dan Mbanga, who leads on technology and business initiatives at Amazon AWS, particularly the AI platforms and Amazon SageMaker. Welcome, Dan.
Thank you, Paco. Thanks for having me.
Super impressed with the keynote this morning, and I'm really glad to see all the deep integration with Jupyter and just the whole pipeline and forethought of process that's going into SageMaker. It's interesting because from a personal perspective, I started out working on AWS as a customer in 2006. I guess it's 12 years now.
Wow.
Of cloud.
Really good.
So I'm super glad about what you all have built up. Have there been traditions coming out of Amazon's work at enormous scale, but also enormous reliability? Has any of those kind of traditions in Amazon engineering factored into AWS and the offerings now with AI?
Absolutely, and that's the story for multiple products, including the machine learning products now. If you look at our database products, you know, the databases that exist in the open source world that we took, or the commercial world as well, that we package in ways that we can put into the AWS platform. That usually comes from the needs that we've had from Amazon, other businesses or internal businesses, the needs to build platforms and solutions and technologies at scale. And in understanding how to do that, we can now port that into SageMaker or into Amazon Web Services and wrap, you know, APIs and web services and scalable means around that in order to bring that to customers. So we've done that with databases. We've done that with automation and DevOps, the CloudFormation, Beanstalk, and code commit, code pipeline, and all these products usually come from some experience that we've had inside Amazon.
Probably security measures, VPC.
Exactly, security measures, yeah. And then at Amazon, security is job zero, really. So we start from security, and we've had to design new protocol and new communication mechanisms just to make sure that we handle security at a massive scale. So we learn a lot from internal customers, and that really brings in, you know, the leadership that we provide, you know, into the machine learning platforms that we build.
And it strikes me that it's also very deep bench in terms of process. It's not just exposing APIs, but it's a matter of working through the process that the customer has to go through to be successful.
Yeah. If you look at EMR, and you said that you've had experience using Elastic MapReduce. Well, some customers asked us, why did you have to build another platform for the purpose of machine learning if there was, you know, Spark and Spark ML already doable on EMR? Yeah. And that's a fair question. But if you look at a process that, you know, a customer has to go through if they have to build a machine learning product from their own data set, the traditional big data ecosystem was built really for the MapReduce type of, you know, jobs where you have independent workers that are working separately, and then one can die, but, you know, the others can continue the workload. But in the world of machine learning, you have multiple machines that have to concurrently observe the same error. They have to be minimizing the same error. So the architecture there is slightly different. And so understanding that for our own business problems, and then understanding that our customers would need that when they start hitting the level of scales, the scale that Amazon.com has today, we built SageMaker to really follow customers through the process of building, training, tuning, and deploying machine learning models with a platform that understands machine learning, with a platform that can concurrently train a machine learning model with machines that are seeing the same state at all times. And that's fundamentally different from the big data ecosystem.
I imagine it has a lot of impact even on data center architecture, network topology.
Absolutely.
Very fundamental.
Yeah, and you know, we covered that in keynote today. At Amazon, at AWS, I mean, we released up to 100, you know, major releases since the announcement of SageMaker at reInvent last year. A lot of them, when we do present, are not really visible, right? Because if we've done an optimization for the CUDA drivers in the back end to make sure that your deep learning code can efficiently talk to the hardware, we won't put that in slides. But there's been more than 100 of those improvements happening to make sure that the algorithms can work efficiently with the back end servers. But we don't want customers to worry about that, because that's not, you want to construct an algorithm. You want to train your models on your data set, and you don't want to worry about how efficient is the communication between the machines. So the back-end operations and optimization and all the C++ code is really taken care of by us. But we want customers to have the same level of depth and flexibility that they would have as if they were, owning their entire end-to-end infrastructure.
Well, another way to put this too is I can imagine your team is very busy.
Absolutely.
And I'm familiar with some of the culture inside of AWS and the notion of being prepared on game day for anything, absolutely anything to happen. So thank you for all that diligence. I know how hard it is.
Thank you so much. Thank you. Well, the truth is 90 to 95% of our roadmap is actually provided by our customers. So part of my job is to make sure that I do have these kind of interactions with AWS customers and folks that have been using the platform, folks that are innovating on top of the platform, and get the needs that they have in order to bring that back to our engineering team, and then build the products that they need. So yes, we're busy building things, but we also busy talking to customers in order to find out the community, find out what they want, and that's really the direct conduit to the products that we're building.
I recall that you and your team were here last year at JupyterCon.
Are they here today?
And here today, but, really doing the research, being out in the community at the very first conference for Jupyter.
That's correct. That's correct.
Wonderful. One thing I've been wanting to ask, we've been measuring a bit some changes in industry with regards to machine learning. We recently did this big survey across the world, had 8,000 respondents, and we were surprised by some of the aggregate results coming back about machine learning in enterprise. And one of the things I think that's afoot is there was an expectation that machine learning is developed over here, and you just throw it over the wall and operations runs it. But what I'm seeing out of SageMaker is there's a lot of forethought put into the process and the operationalization of the machine learning models. There's 3 stages, I understand how that works. Could you describe a bit more about that?
Yeah, absolutely. And so just for some history, I started at AWS 5 years ago, where I was leading 2 teams. I was leading the big data support engineering team and then the DevOps team. And then those were 2 emerging technologies at the time, so to say, and the same paradigm applied back then, right? Where you had a few that knew how to do that very well, but the product hadn't matured. The products that existed out there hadn't matured to the point where they can get into the hands of many other consumers, and they would be able to use that efficiently. And so what we've done with EMR, for example, packaging the Hadoop software libraries and packaging Spark and packaging, you name it, Flink and all of these big data tools in a way that would really make it easy for a lot of people without all the Hadoop backend experience to spin up an infrastructure and say, I want Spark 2.0, I want this and I want that, and have that entire infrastructure built for them in an automated way. The same paradigm applies to SageMaker. So the slight difference is that, and you're right, so the slight difference is that the machine learning and AI ecosystem really is out there. Everyone is interested in it. The masses and all customers and all enterprises and startups, everyone has a use case for machine learning. Right. But not everyone has the background or the education or the maths and all the things that you need to do in order to build a machine learning platform from scratch. So what we set to do is, what are the units of packaging that we can have in order to put these capabilities in the hands of the people that can build their own models, that can build their own solutions without having to figure out everything. And what is the workflow? Right. And we're thinking about it in 3 major lanes or pillars. And I spoke about that today. There's the accessibility aspect of it, there's the reproducibility aspect of it, and then there is the momentum aspect of it, where you can get the access and then the way to reproduce stuff, and then you can actually carry all of that and then accelerate in order to solve your business problems. So the parts of SageMaker to solve all of these problems the first part is the build ecosystem. Okay. Like, where do people build machine learning solutions? Okay. And then for that, we make Jupyter Notebooks available, because those are really Jupyter Notebooks are the tools that everyone uses now, from education to enterprises to startups to the community to pretty much everywhere. Research, finance, economy. So in all of those areas, and then that was direct feedback from our customers saying, well, we want Jupyter Notebooks in order to do machine learning. So the build phase provide pre-built Jupyter Notebook environments, and with a few clicks, you can actually get a notebook running for you.
Oh,
the only decision you have to make as a customer is to say, well, I want this much power in a machine that is going to back this Jupyter Notebook, right? So you could say you want that on a machine with about, 4 gigs of memory or 16 gigs of memory, or you could say you want a GPU-powered machine backing that Jupyter Notebooks because you want to do experiments on Jupyter Notebooks. So we package all of that and we make it available. The second thing that we do there is to make sure that there are high-performance built-in algorithms that are available in these Jupyter Notebooks, and every single one of these built-in algorithms has an example Jupyter Notebook associated to it.
Excellent.
Right, so we won't just say, well, use XGBoost.
Right.
We made it available, but we would say, well, this is an example on how to predict customer churn using XGBoost on SageMaker in a Jupyter Notebook.
Excellent.
And that brings us to the reproducibility, because now you have a platform that can get powered in a matter of seconds, and then you get an examples in a Jupyter Notebook that you can reproduce. And I've seen multiple customers just using our examples, taking our data out of it, bringing in their own data in the
Right.
format that is required, and solving production problems
Right.
really, really fast. And then so the concept of scaling behind that is really our way to think, well, what are the most popular machine learning and deep learning libraries that exist out there, and what are the access points of friction that some people have
Right.
in order. So imagine you want to use, you read a paper and the example code is in PyTorch. Now you have to figure out how to build a PyTorch environment for yourself. But what about you just have an API that you can call that brings in the PyTorch container, and it doesn't just bring in the container, it also brings in the possibility to scale that environment.
Interesting.
It brings in the possibility to
Sure.
go get the data from the storage environment and bring that all to the cluster, all the things required sharding and all that.
And that's been one of the issues with PyTorch versus Cafe. I mean,
Yeah.
you do in one format and you do some training and then you scale it up in another, maybe switch to Cafe. But
Exactly.
now you could actually do this all in PyTorch.
All
and
in
use the
PyTorch.
cloud.
And use the cloud. So, and then it's all really a way to treat the cloud as an API that you can call.
Yeah.
And that would provide an intelligent platform that understands machine learning, that comes in pre-configured with a framework that you are interested in, and that knows how to get the data at scale, stream the data through the platform, and we can talk about streaming in a second. I know you're interested in
Yeah.
that. And also distribute the job among all the machines. And you know, big data and machine learning. People distribute data for the purpose of performance computing through things like MPI, or now with new paradigms like NWCL, or things like parameter servers. So there are multiple ways, different tools distribute the data for training, machine learning models. And those are the kind of things that customers have to learn in order to even just start using these products.
It's a high learning curve.
And that's what we take away.
Exactly.
So we say, well, bring your PyTorch script, or bring your TensorFlow script, bring your MXNet script, or bring any machine learning script you have. We have the packaging that is required for that. And that packaging knows how to distribute itself to 1,000 machines if you're interested in.
Oh.
And then, so that's really the benefit. That's one of the secrets of the platform. And the interface, because it's based on most of the open source tools that are out there, people that are using SageMaker are actually, there's no, as long as you can write Python, as long as you can write some PyTorch code, just go and start using that today.
Wonderful. Well, and also we should mention that reproducibility is where a lot of other important characteristics come in terms of transparency of models, validation, some of the concerns about privacy, security, ethics, not of the infrastructure as much as what's going into the model. Mm-hmm. And so by reproducibility, now the enterprise customers can also begin to get toward the compliance that they have.
Right.
Even another learning curve and high bar.
And the community as well, right? To get back to your previous question on now bringing the technology from the hands of a few into the hands of the masses, and then, having a playing field where you can get access to templates and examples and packaged algorithms and all of these things. Now what you have to start thinking about is, well, how do you organize your data, because that's your part of your secret sauce. But more importantly, maybe your data model. How do you look at that data, and how do you, generate insights out of that data? And then privacy kicks in, right? Security kicks in. Yeah. And at Amazon or Amazon Web Services, security is job zero. We start from security. Right. And that's why we work with customers in financial services, highly regulated environments, customers like Moody's, customers like FINRA, and many other customers like Capital One are building machine learning solutions on top of the AWS platform. And we also have customers in healthcare, like GE Healthcare, that are basically revolutionizing the way you can look at data and the way you can empower physicians on the decisions that they make from the insights that they generated from the results of a deep learning model. We have customers like Celgene that are accelerating the process of bringing a drug to the market by analyzing the toxicity out of a drug test really, really rapidly by using the P3 instances on AWS and the Volta, NVIDIA Volta GPU. And then packaging all of that and analyzing that with deep learning models that they built with Gluon. So all of those primitives are really wrapped around strong security models. Yeah. And it's a shared responsibility, right? So from our side, what we say is, well, we'll bring in the platform, we'll bring in the distribution, we'll bring in the scale, and we'll also bring in the security. And then from your side, what you have to do is to, configure your environment on AWS, with the security tools that are provided to you. Right. For example, the data store, Amazon S3, is scalable, and it has a way for you to set the security on the data itself. Right. And this is really powerful. If you want to think about reproducibility, if you want to think about a template, and I make my data set available to multiple departments within the company, but I decide who can access that because I can put the security on the data set itself, right. And then you can spin up your platform and infrastructure, and then you can consume that data set from me. And if I don't give you access at the data level, you won't be able to access that.
So it's a control plane, not a perimeter.
Fine-grained access control at multiple levels, at the data level, at the object level, at the platform level, pretty much everywhere we could inject security, we put security. We're very serious about that.
Absolutely. Now, we've talked about accessibility, we've talked about reproducibility. There's a third stage as well.
Yeah, which is momentum, right? So the way I think about momentum is, how, I made this joke today where I said it's called envy. And so, but if you look at that, this is really how you can take something that is small or big and apply velocity to that, right? What is the size of your infrastructure? What is the size of your problem? What is the size of your data? Sure. What are the mechanisms that could be put in place for you to apply velocity on top of 1 terabyte, 10 terabytes of data? Right. That's really what I mean by momentum. And then how often do you deploy machine learning models? How does it take for you to get to the point where you're happy with your models in production?
Sure.
And how can we reduce that time frame? So that's what I mean by momentum. So when you have accessibility and reproducibility, they really naturally fit into the momentum piece. Where with SageMaker, we see customers like Intuit dramatically reducing the amount of time it takes for them to routinely deploy machine learning models into production from about 6 months in the past to 1 week now.
See, and that's the pain point that we're seeing is a lot of engineering departments don't really have the mindset yet. You think of when you're building an architecture, you put your best people up front, you come up with your API definitions, and you put a lot of work up front, and then it's a lot of detail work. Mm-hmm. More junior people do detail work. And that's great for web development. But with machine learning, the early parts of it are easy. It's like a homework problem to train a model if you're given a data set. Once you're in production, though, that's where you really have to have your best people, and that's where you have to iterate quickly, and you have to do weekly updates or daily updates. So I think this is fantastic because it's a very different kind of engineering process, but it's what's absolutely crucial for AI.
Mm-hmm. And there are two pieces of really opportunities for achieving momentum. We spoke about streaming, streaming data. So assuming that you have an ecosystem that keeps growing, right? You keep getting more and more data. And maybe because you're using SageMaker as a platform that helps you accelerate the process of building, training, and deploying a machine learning model by taking part of the back-end responsibilities away from your team, you get more time for innovation, right? So again, you're accelerating. But then your data size grows to really, really large amounts. And now you get to have the kind of problems where you have GPU starvation, where the GPUs are waiting for the data, but the time to get the data from the storage to load that into the machine. It's the traditional way of building machine learning training model platforms. So what we've done there to again increase the momentum is to have the concept that we call streaming SageMaker streaming algorithms, which is what we've done with Amazon-provided algorithms that exist in SageMaker. But some of our customers said, well, we want that for TensorFlow as well. We want that for PyTorch and other frameworks. Yeah. So with streaming, really what we do is that we make it possible for the infrastructure, as soon as it started, to start seeing the data coming from the cloud storage. What that means is that you might have 10 terabytes of data on the storage, but there's this kind of buffer that is created between the infrastructure and the storage that streams the data directly, so your machine learning model can start training already. And because most of these models deal with many batches of data at a time, you actually don't need the whole 10 terabytes attached to the model in memory before you start training. So that's the problem we've solved, where your model can start training faster, and ultimately it will end faster because, it starts faster, and because we also apply the process of single pass training, you don't have to pass the data over and over again. That's a fundamental architectural change at the, platform level that we've done in SageMaker to ensure that people can already start training and then already start observing the results even as the data keeps pouring through the platform. So that's the streaming approach. And that increases the momentum in the training phase. On the productionizing phase of machine learning models, there are two ways of looking at it. One is, I have a model that is hooked to a real-time application, like a transactional system, and I want to send requests for the prediction, right? I want to send requests for the magic of machine learning to come in real time. And so in that environment, we provide a hosting environment that is easy to get started, and it exposes an endpoint that is secured, to which your application can send requests and get the predictions, right? So it's real-time API, and in the back end, again, we take care of auto-scaling, including multiple availability zones, so multiple AZs, to ensure high availability. Now, the other thing is you might have, a list of transactions from last month, and you want to analyze the lineage or some other type of things there that is really batch processing. Right. It is not real-time, processing. Or you might analyze video data, and you have very large video data, and you can't send that to an endpoint. Yeah. So for that, we recently announced batch transformation jobs, basically in SageMaker. That really treats the process of scoring machine learning models as a batch job. So it really feels like EMR. It really feels, where you can just say, hey, SageMaker, give me 1,000 machines for my last year's large-scale job, and I have this machine learning model. I want to use that for scoring all of them. And boom, you get the infrastructure, process all your scoring, and then generate the results and push that back to the cloud storage.
So I can imagine that helps out a lot for organizations that already have those batch jobs running, and now they want to migrate up to more sophisticated machine learning.
Exactly.
It's a much easier path.
Exactly. And that's really, again, accelerates the process of getting to the making a decision that is data-driven or having a product go into production without having to worry about all the data passing, the infrastructure building, clustering, all of these things are taken care of, and it's a simple API call.
Wonderful. Alrighty. Thank you very much, Dan.
Thank you so much, Paco. Thanks for having me.